Hello students, welcome to chemistry class. So in the last class we have studied about how to express the concentration of the solution. That is different methods to be used to express the concentration of the solution. So concentration is nothing but amount of solute present in the given quantity of solvent. Let us see what are the methods to be used to express the concentration of the solution. That is mass percentage method. That is W bar W percentage, that is equal to mass of the solute divided by total mass of the components present in the solution. Here 1 indicates solvent and 2 indicates solute. So 1 indicates the solvent and 2 indicates the solute. That is weight of the solute divided by total weight of the solute and solvent into 100. That is mass percentage method. And volume percentage is nothing but the volume of the solute divided by total volume of the solutions or the components present in the solution. Right? So that is V2 divided by V1 plus V2 into 100. And the next method, that is mass by volume percentage. That is mass is W and volume is V. That is mass of the solute divided by volume of the solution in ml into 100. So weight of the solute divided by volume of the solution in milliliters into 100. And a few more methods to be used to express the concentration. Generally, these methods are to be used in the competitive exams. That is how to calculate the strength of the solution. That is mass fraction of the solution and normality, formality, demal. So all these to be asked in the competitive exams. So very important formulas to calculate the concentration of the solutions for theory as well as for the competitive exams. That is strength. So strength of the solution, that is unit for strength is grams per liter, right? So grams, that is mass of the solute in grams divided by volume of the solution in ml into 1000. If the volume of the solution is in liter, it is not necessary to multiply with the 1000. That is strength of the solution is defined as the mass of the solute divided by volume of the solution in liter. And next, mass fraction method. So it is not mole fraction method. So it is mass fraction method. So mass fraction method is defined as the mass of the component divided by total masses of the components present in the solution. So it is just like similar to the mole fraction. So in the mole fraction we are using number of moles, but in the mass fraction we are using weight of the components. That is weight of the first component divided by total weight of the components present in the solution. So that is W1 divided by W1 plus W2 for the first component. And mass fraction of the second component is equal to W2 divided by W1 plus W2. So this is to be applicable for the binary solutions. Next method, that is parts per million method. PPM. That is number of parts of the component divided by total number of parts of the components present in the solution into 10 to the power 6. Number of parts are W2, weight of the solute divided by weight of the components present in the solution into 10 to the power 6. So if it is to be multiplied with the 10 to the power 6, then it indicates the parts per million. And next, molarity. So molarity unit is moles per liter. That is weight of the solute into 1000 divided by molar mass of the solute into volume of the solution in ml. So if it is in the liters, it is not necessary to multiply with the 1000, right? Next, molality. So molality unit is mole per kg. Mole per kg. Kg indicates that is weight of the solvent is in grams or kilograms. That is W2 into 1000 divided by M2 into W1. So W2 indicates the weight of the solute into 1000 divided by molecular mass of the solute into weight of the solvent in grams. And there is one more method that is to be called as normality. It is a old method to be used to calculate the concentration of the solution. Nowadays this method is to be replaced with the molarity and molality. So this normality is defined as the weight of the solute divided by equivalent weight of the solute. That is, mass of the solute is W2 into 1000 divided by E2. E2 is nothing but equivalent mass of the solute. So volume of the solution is to be multiplied with the equivalent mass of the solute. So that method is to be called as normality method. And next, one more method, that is Demal method. It is similar to the molarity, but the difference is concentration is to be measured at 0 degree Celsius. So generally molarity is to be calculated at any temperature, but Demal method is to be used to express the concentration only at 0 degree Celsius. And next, mole fraction method, that is X. So mole fraction is defined as for the binary solutions, X1, that is Psi1 is equal to number of moles of the component divided by total number of moles of the components present in the solution. For mass fraction, so it is W1 divided by W1 plus W2. Weight is to be used to express the mass fraction, right? So in the mole fraction, number of moles to be used to express the concentration. That is N1 divided by N1 plus N2, and X2 is equal to N2 divided by N1 plus N2, and X1 plus X2 is equal to 1 for binary solutions. Like that, one more formula that is to be called as formality. So it is to be symbolically represented as F. So it is defined as the number of gram formula mass of the solute, number of gram formula mass of the solute divided by volume of the solution in liters. So if it is in ml, then it is to be multiplied with the 1000. That is, if it is in ml, it is to be multiplied with the 1000, right? So these are the formulas generally to be used to express the concentration of the solutions. Let us see how to calculate the mass percentage of benzene and carbon tetrachloride if 22 grams of benzene is dissolved in 122 grams of carbon tetrachloride. So we have to calculate what is the mass percentage of benzene and carbon tetrachloride. So first we have to calculate, that is, what is the mass of solution. So mass of solution. So mass of solution is the sum of the masses of solute and solvent. So mass of solute is 22 grams, that is solute is benzene, that is mass of benzene plus, so mass of carbon tetrachloride is 122 grams, that is mass of CCl4. So 22 plus 122, that is equal to 144 grams. So the formula to calculate the mass percent of benzene is mass of benzene divided by total mass of solution into 100. So mass of benzene is 22 grams divided by total mass of the solution is 144 grams into 100. So on simplification, so it gives 15.28%. So this is the mass percent of benzene. Next, let us calculate mass percent of CCl4. That is mass of the component. So component is CCl4 divided by total mass of solution into 100. That is equal to mass of CCl4 is 122 grams divided by total mass of the solution is 144 grams into 100. So it is 84.72%. So by adding these 2%, it gives 100%. That is mass percent of benzene is 15.28% and mass percent of CCl4 is 84.72%. And next problem, that is calculate the mole fraction of ethylene glycol in a solution containing 20% of C2H6O2. C2H6O2 means ethylene glycol. So we have to calculate what is the mole fraction of ethylene glycol. So here they have mentioned that is 20% of ethylene glycol. So what is this 20% of ethylene glycol? That is 20% of C2H6O2 by mass. That indicates that mass of C2H6O2 is 20 grams, right? Next, mass of water is equal to 80 grams and mass of solution is equal to 100 grams. So out of 100 grams, 20 grams of ethylene glycol is to be dissolved. And next, let us calculate molar mass of ethylene glycol. Molar mass of C2H6O2. That is 2 into carbon plus 6 into hydrogen plus 2 into oxygen. That is 2 into 12 plus 6 into 1 plus 2 into 16. So finally it gives the value, that is 62 grams per mole, right? Let us see how to calculate the mole fraction. So the formula for the mole fraction is, that is X C2H6O2 mole fraction of ethylene glycol is number of moles of ethylene glycol divided by total number of moles of ethylene glycol plus number of moles of H2, right? So first calculate the number of moles of ethylene glycol and number of moles of water. So first calculate number of moles of C2H6O2. That is, number of moles is to be calculated by using the formula mass of the component divided by molar mass. Mass of C2H6O2 divided by molar mass of C2H6O2. So mass of ethylene glycol is 20 grams divided by molar mass of ethylene glycol is 62 grams per mole. So on simplification, it gives 0.322 moles. Next, let us calculate number of moles of water. So mass of water is 80 grams divided by molar mass of water is 18 grams per mole, and then on simplification finally it gives 4.444 moles. Let us calculate the mole fraction of ethylene glycol C2H6O2, that is number of moles of C2H6O2 divided by number of moles of C2H6O2 plus number of moles of H2O. That is number of moles of ethylene glycol is 0.322 moles divided by number of moles of ethylene glycol, so it is 0.322 moles plus number of moles of water. So number of moles of water is 4.444 moles. So on simplification it gives 0.068. Similarly, mole fraction of water is equal to 1 minus mole fraction of ethylene glycol C2H6O2, that is 1 minus 0.068, that is equal to 0.932. So the mole fraction of the ethylene glycol is 0.068 and the mole fraction of the water is 0.932. So this is the method used to calculate the mole fraction of the components present in the solution. So the solution contains only 20% of ethylene glycol. 20% of ethylene glycol means 20 grams of ethylene glycol is to be mixed with the 80 grams of water, and finally it gives the 100 grams of the solution. Let us take one more problem to calculate the mole fraction, that is calculate the mole fraction of benzene in a solution containing 30% by mass in CCl4. 30% by mass in CCl4, that is 30% by mass means mass of benzene is equal to 30 grams and mass of CCl4 is equal to 70 grams and mass of solution is equal to 100 grams, right? So 30% by mass means 30 grams of benzene is to be dissolved in the 70 grams of CCl4. Finally it gives 100 grams of solution. So let us calculate molar mass of benzene, that is molar mass of benzene is 78 grams per mole and molar mass of CCl4 carbon tetrachloride, so its molar mass is 154 grams per mole, and calculate the number of moles of benzene, that is number of moles of C6H6 is equal to mass of benzene divided by molar mass of benzene. So mass of benzene is 30 grams divided by molar mass of benzene is 78 grams per mole, So on simplification, it gives 0.38 moles. Similarly, calculate the number of moles of CCl4. So number of moles of CCl4 is equal to mass of CCl4 is 70 grams divided by molar mass of the CCl4 is 154 grams per mole. On simplification, it gives 0.455 moles. Let us see how to calculate the mole fraction. So mole fraction of benzene C6H6 is equal to number of moles of benzene divided by number of moles of benzene plus number of moles of carbon tetrachloride. So number of moles of benzene is 0.385 divided by 0.385 plus 0.455. So on simplification, so it gives 0.458. Similarly, the mole fraction of CCl4 is equal to 1 minus 0.458. So it is 0.542. So the mole fraction of benzene is 0.458 and the mole fraction of the carbon tetrachloride is 0.542. So this is the method used to calculate the mole fraction of the components present in the solutions.